Now, the next topic that we are going to talk about is called the Pythagoras Theorem. Now, from this moment on, we are going to be spending a lot of time on right angle triangle. And one of the basic results about the sides, necessarily important, this is a result about the sides of a right triangle, is called the Pythagoras Theorem. Now, recall, we learned the nomenclature for the sides of a triangle. If you have this right angle here, the side that is opposite, which is facing this, is called the hypotenuse. The other two sides on which the triangle rests is called the legs of the triangle. Okay. Now here's the theorem. First of all, we need to know how to label the triangle. We'll use capital letter for the vertices or the corners of triangle, and we use small case letters for the sides. And how we label them is, if this vertex is A, then the side opposite that is small a. If this vertex is B, the side opposite that is small b. And if this is C, then the side opposite that is small c. If you set it up in this way, then the theorem says a squared plus b squared equals c squared. But that depends on the labels A, B, and C, right? So the more accurate form is that the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Example, let's say in this figure, I am given two sides being 12 and 5 and I have to find the third. So I label according to opposite. So A gives me A, B, and C. I get the legs are AC and that's AC. AC is this side. And BC, which is this one. So I get AC squared plus BC squared equals AB squared. Or I solve this, and to get rid of the square, remember from week 1, we learned about the square root as an operation that undoes the squaring operation. Right, so we take a square root and we get C equals 13 centimeter. So get an example of a word problem. You can pause the video at this point, read this problem right now, and try to solve it on your own. The pole is on level ground and perpendicular to the ground. Wires that brace the pole on either side are attached to the top of the pole. Each wire is 25.0 feet long and the pole is 20 feet high. How far are the grounded ends of the wires from each other? In general, problem-solving strategy involves these steps. Step 1. Identify the objects in the problem. What are the things that the problem is talking about? Over here, you can identify the objects as being a pole, a ground, and some wires. Step 2. Identify the relationship between these objects. Here, the pole is perpendicular to ground. The wires are attached to either side of pole, which means there's two wires. Wires attached to the ground, so they go from the pole to the ground. Step 3. Draw a neat diagram. So here is the information I have. I have a pole, I have ground, and I have wires. The pole is perpendicular to the ground, so that's 90 degrees. Wires go from either end of the pole and they attach to the ground. Then you can label what is known and what is to be found. We know the pole is 20 feet high. We know the wires are 25 feet long each, and we are trying to find the distance between the 2 points on the ground. Now these are both x because, well, if you notice that in the right triangle, if two sides are equal, in two right triangles, if two sides are equal, then all sides are equal. So I can label the unknown, both of them, as x. Now identify the tool to be used. Step 5 is important because although right now you only have one tool, going ahead we will be learning a bunch of different tools, so it becomes important to identify what to use. Here, because we are talking about a right triangle and we are talking about the lengths of the sides, we use Pythagoras theorem. So that for the small triangle, we apply the Pythagoras theorem, get x squared plus 20 squared is 25 squared, giving us x squared is 225 and x is 15 feet. And the distance between the two ends is 2x, so it is 2 times 15, which is 30 feet. Now, each word problem is unique, and I can't give you a method that works for all of them. But this serves as a good general guideline if you follow these 5 steps in order to process a word problem. That's it for this week.